In this video, I'm going to go over this question where you're given a function and you're told to find the values of the constants a and b such that there exists a maximum value of f at 7 equals 35. To start, we're told that f at 7 is equal to 35. This means that when x is equal to 7, there is a maximum value of 35. And we're given this function. Now recall from derivatives that a maximum can occur whenever you take the derivative of a function. And then if you set that derivative equal to 0, you can find your critical points, and that is where a maximum or a minimum occurs. So what we have to do is we first have to take the derivative of f of x and see what happens. Now keep in mind that a is a constant, and using the constant multiple rule, we can leave it alone and just differentiate everything else. So let's go ahead and do that. We can say f prime of x is equal to a multiplied by the derivative of the first function, x, which is going to be 1, multiplied by the second function, which is going to be e to the negative x squared over b, plus the first function multiplied by the derivative of the second function. Now, what's the derivative of the second function? Well, let me rewrite this in a different way, the exponent. This is the same thing as writing 1 over b multiplied by negative x squared. Now, 1 over b you can treat as a constant, and according to the constant multiple rule, we can just leave it out in front and just differentiate negative x squared. So doing that, you're going to get negative 2x over b as the derivative. And now we can close up the brackets. And once again, to reiterate, a is a constant, and according to the constant multiple rule, we can leave that out in front and not worry about it. We'll multiply it in at the end. We're just taking the derivative of the first function we're calling x, and the second function we're calling e to the negative x squared over b. I can now go ahead and simplify this. I notice that we have a negative 2x here, and we also have an x here. And so I can simply change this positive to a negative because of this negative here. And by multiplying this 2x and the x together, we're going to get 2x squared. So let's go ahead and do that. This is equal to a multiplied by e to the negative x squared over b minus 2x squared multiplied by e to the negative x squared over b, all divided by b. Now I'm going to go ahead and multiply in this a that we were talking about earlier into both. So we can say that this is equal to ae to the negative x squared over b minus 2ax squared e negative x squared over b divided by b. Now, I want to set this equal to 0 and try to solve for b. That would be the easiest thing to do right here. However, right now this function is not written in a way where it's manageable to do that. So we should look at this function first and see if we can factor anything. We see that we have an ae to the negative x squared over b here. And likewise, we have an a here, and we have an e to the negative x squared over b here. So we can actually go ahead and common factor that out. So this is equal to ae to the negative x squared over b, all multiplied by 1 minus 2x squared over b. And if you don't believe me, just multiply this back out. You're going to get the exact same thing here again. So ae to the negative x squared over b multiplied by 1 is going to give us this. And then ae to the negative x squared over b multiplied by negative 2x squared over b is going to give us this. And so all we have to do is set our first derivative equal to 0. Now, what are we actually going to solve for here? Well, this function right here, this is always greater than 1 because of this e to the negative x squared over b. If you graph this on Desmos, it is always above the x-axis. It will never be below 0, nor will it touch 0. So all we're going to do is just set 0 equal to this function right here. And then we can solve for b, because we know the value of x already, which is 7. So we can say 0 is equal to 1 minus 2x squared over b. And then I can move the 2x squared over b to the other side. I can now go ahead and cross multiply. And so b is equal to 2 multiplied by our x value, which was given as 7. And that is going to be squared. And so our b value turns out to be 98. Now what about our a value? Well, we are told that f at 7 is equal to 35. Why don't we use the original function as a piece of information? So we know that f at 7 is equal to 35. And so wherever I see an x, I'm going to plug in a 7. Now this will be a multiplied by 7 e to the power of negative x squared. So for x, I'm going to plug in 7, square that, divided by b, which we just found out to be 98. And so this is going to be equal to 35 equals 7a e to the negative 49 over 98. And then I can simplify this down. I can see that this is equal to 35 equals 7a e to the negative a half, because this reduces down to 1/2, negative a half. And so now I can divide both sides by 7. This gives me 5 equals a divided by the square root of e. And then solving for a, we get a is equal to 5 root e. And so therefore, we can say that a is equal to 5 root e and b is equal to 98. And so now that we found our constants a and b, if we go ahead and graph this function on Desmos, we see that there is indeed a maximum value of 35 when x is equal to 7. And so let's say on a test this question were to show up, and you go through all of these steps to solve for a and b, and you want to make sure that you didn't mess up anything. Simply just take your x value, which is 7, or whatever it may be, plug it in for x, and it should equal 35. If it equals 35, it means you did everything correctly.